So what about quantum? Now I have the challenge, I should make it unfastbar and so on and so forth, and then the last thing which is standing between you and your dinner. So it's a challenge. So, well, trying to make it unfastbar, I would like to start by telling that every single person in this room carries in their pocket quantum technologies. So I also have one. So electronics is made with electrons. So how can you use electrons without quantum mechanics? They are quantum objects. So you must be able to master the laws of quantum mechanics to have digital technologies. Digital means zeros and ones, means switching on and off. But for every 0 and 1, I have a very many electrons, thousands, maybe more, which are going around. Now, this is the first quantum revolution, so it's old stuff. And now I brought another surprise for you. It is in my pocket, my left pocket of my trousers, and maybe some of you know that it exists, but probably most of you have not yet seen it. This is a Samsung Galaxy Quantum. Since nowadays the only source of truth is what you can see on a mobile phone screen, I will switch it on so you can trust me. So this is the first device of the second quantum revolution. What does it do? It doesn't do quantum communication yet. It doesn't do quantum computing yet. It has a random number generator, which is based on single photons. How does it work? This allows me to tell a little bit the principles of quantum technologies. So it's about taking quantum 2.0, one quantum at a time. If I take individual quantum systems, what happens is that they can be in superposition. So like in this picture, it's both possibilities. You know, it's like 0 and 1 at the same time. And when you look at the picture, you will see one of the two. It kind of collapses, and it does it in a random way. There is no way to predict it. And so this is a random number generator, which is used to make classical communications much more secure. But this is just one qubit. Now, if I have two, one at a time, as we said, so there I get entanglement. So if I prepare two quantum systems in this kind of state, they will collapse when I look at them, either both down or both up, but they will be correlated. I can do many things with this. For instance, I can do teleportation. Actual quantum teleportation is much more exciting than Star Trek teleportation, but we don't have the time today because I have to talk about other things which has been mentioned before. But these are very delicate states. You can use them, for instance, for sensing. We will see examples afterwards. You can use them also for computing. What about quantum computing? This is when you use the power of entanglement. So it means that, let's imagine that I'm in a labyrinth. I have to solve a problem getting out of that. How do I do that? Well, I will try, I go left, I go right, then maybe I end up in a Sackgasse, yeah? And then I have to go back and to say, okay, let me try another one. I have to try all possibilities one after the other because I'm a classical thing. If I would be a quantum bit, at every point in the labyrinth, I could bifurcate. I could go both left and right, and in one go, I get to the final goal. So this seems pretty much science fiction, obviously. It actually was science fiction when I was a student, and now it's something which starts being practical. For instance, I showed this little device, and there is one wonderful and sad story, which I have in my other pocket. This one is the quantum random number generator 2.5 millimeter squares, which is in that phone. When I was a student, this thing took the surface of 3 of these tables filled with mirrors, lenses, detectors, lasers. And it was miniaturized. Where? It was miniaturized in Europe, right? So we can be very proud. And I will say, wait a moment. Chip made in Europe. Phone made in South Korea. Why? I know another story like that. The web was invented by physicists, I'm a physicist, very proud, in Geneva, at CERN. Where is the cache? In California. Why? What if this time we were able to get innovation, as was mentioned before? What if we were able to make our own companies? Actually, we already are doing that. We have startups from our European and national quantum program, and we have those quantum processors which are all over the place. Those are the pink ones. Pink is my favorite color. So they are combined with AI factories. There are a few places in Europe, by the way, in which they are co-located. As a matter of fact, if we zoom a little bit onto our beautiful country, there is one place in which is one of the 4 at European level, in which we have the AI factory and the infrastructure for quantum computing and simulation. And this is belonging to Helmholtz. Maybe not by chance. Because what if we would not just discover things? We would not just build devices. We would not just make it available for use, but we would create a virtuous circle in which we discover, we build, we use, and then we learn what we have to research further, to discover, to build, to use, and so on. So this is something that we can do at Helmholtz, because at Helmholtz we have both technology makers and the technology takers, and we have seen a couple of examples, so that's why we created this Quantum Use Challenge. So this is about taking people out of their cozy box and making them talk to other people which can use this technology. And here are some examples. For instance, we spoke, I promise, I didn't make this slide based on the predecessors, and I didn't know I was the last, but honestly, this is using a quantum computer for fluidodynamics, calculating properties of and predicting properties of water from droplet to big water reservoirs for water management. It's about developing using quantum computers for developing, accelerating the development of new drugs. It's about using entanglement, what we said before, for sensing the earliest and most precise detection of cancer cells. And I don't have to argue about that, so it's wonderful. Thank you for the introduction. And it's about, as was mentioned also in the introduction, about using quantum simulators to better understand batteries and to make new batteries more performant for supporting our energy transformation and our economy as well. So this is the idea of the Helmholtz Quantum Challenge, and the main point, the only takeaway, is this one: quantum is coming.